All right, today we're diving into something really cool in AI. What if instead of teaching an AI by showing it thousands of examples, you could just give it one single perfect instruction? Well, that's the promise of a seriously game-changing paper we're unpacking today, a method that could make AI smarter, faster, and a whole lot cheaper to use. But before we get into that, let's start with a question. We hear all this buzz about these super powerful AI models, right? But what's the catch? What's the hidden cost of getting them to do something new and useful for us? As it turns out, that price tag can be surprisingly steep. So here's the deal. These large language models, or LLMs, they're kind of like these brilliant students who know a little bit about everything. But if you want to teach them a very specific new skill, say spotting spam emails, you have to use a ton of computational power. And every single time it analyzes an email, that costs real time and real money. Okay, so how do we deal with this right now? Well, let's take a look at the standard way of doing things, which is something called in-context learning. Think of this as the old school established way of getting an AI up to speed. So in-context learning, ICL for short, imagine this. You hire a new employee, and to teach them their job, you just drop a giant stack of finished work on their desk, both good and bad examples, and you're just like, go for it. Figure out the pattern. You're not giving them the rules, you're just hoping they get it. And this is where you hit the big trade-off. I mean, on the one hand, hey, it works. You get pretty good performance out of the AI. But the downside? It's huge. Because you have to cram all those examples into the prompt. The prompt itself gets super long. And longer prompts, that means way higher costs and way slower answers. This whole thing feels a little clunky, right? A bit brute force. It really makes you wonder, there's got to be a smarter, more elegant way to teach an AI, right? And the answer from this new research is a huge, resounding yes. The big idea here is a concept they're calling instruction induction. The thinking is, instead of just showing the AI tons of answers, what if we could just teach it to understand the question perfectly from the get-go? So, instruction induction is all about being super efficient. It's this incredible process of taking all those examples, dozens, maybe hundreds of them, and just compressing them, boiling them all down into one single, short, but perfectly descriptive instruction. It's literally like turning a 10-page manual into one perfect sentence. And the actual method from the paper that pulls this off is called Prompt-MII. It was developed by an awesome team of researchers, including Emily Shao. You can think of it as this expert teacher that's been trained to write that perfect one-sentence instruction for basically any task you can throw at it. How does it actually work? Well, Prompt-MII was trained on over 3,000 different data sets. It uses something called reinforcement learning, which is kind of like playing that hot or cold game. The AI tries writing an instruction, it gets feedback. Nope, that wasn't great, or ooh, that was better, and it adjusts. It's trial and error on a massive scale until it gets really, really good at creating the best possible instruction for any new task it sees for the first time. Okay, so that all sounds amazing in theory, right? But does it actually hold up in the real world? Well, this is where things get really, really exciting. Let's dig into the results, because honestly, they're pretty mind-blowing. First up, let's talk efficiency. The instructions made by Prompt-MII need anywhere from 3 to 13 times fewer tokens than the old method. I mean, that is a massive leap forward, a huge reduction in cost and complexity. And this chart here just makes it so obvious. That big, tall bar, that's the super high cost of the old way, ICL. And that tiny little bar next to it, yep, that's Prompt-MII. The difference is just night and day. And that difference translates directly into saving a ton of time and a ton of money. But here's the absolute kicker. You get all that incredible efficiency without losing any quality. The paper says it right there. It matches the performance of the older method. This isn't a trade-off. You're not sacrificing performance for speed. You're just getting a better system. Full stop. Actually, wait, it gets even better than that. When they threw 90 brand new, completely unseen tasks at it, Prompt-MII didn't just match the performance, it actually improved it in a lot of cases by about 10 to 20%. So it's not just smaller and faster, it's very often better. Okay, let's just recap. We have a new method that is smaller, faster, and even better a lot of the time. This is way more than just a cool academic paper. So what does this actually mean for all of us, in the real world? Why should you care? Well, the implications here they're huge. For you and me, this could mean that the AI apps on our phones get way faster, way more responsive. For developers, for startups, this is a game changer. It lowers the cost of building with AI so much that it could just unleash this huge wave of innovation. Everything from smarter customer service bots to more accurate medical tools. And on a global scale, making AI this much more efficient, that seriously reduces its environmental footprint. And that really brings us to a final, pretty big thought. This whole thing, it isn't just about efficiency, right? It's about teaching an AI how to teach itself more effectively. It's a real step towards more autonomous, more truly intelligent systems. So I'll leave you with this question to chew on. If an AI can learn to write its own instructions this well, what can't it learn to do?